In this example, we're using the law of sines to solve for all possible triangles given some information. The first step is to actually, let's just draw our triangle. And it's just any old triangle, nothing special there. A here, B here. See there, you could put A at the top, B at the left, whatever, it doesn't matter. We just have angles A, B, and C. And then across from those, we're going to have a point, side. So little a's here, little b's here, little c's here. See how that's across? A's across from A, B's across from B, C's across from C. That's how they're assuming your triangle is set up. That's what they're assuming. So you have to set it up like that so that you're speaking the same language they are. So that's what they're assuming. So, and now let's take what they give us. Angle B is 50 degrees. So angle B right here is 50 degrees. Little a is 104, and little b is 44. Okay, so there's the information they're giving us. Let's go through it. So first off, we're supposed to find angle A. Well, how are we going to do it? Well, there's no right triangles here, right? There's no right triangle, so we can't use SOHCAHTOA. That's only for right triangles because SOHCAHTOA, that has an H in it, which stands for hypotenuse, which means you have a right triangle, the hypotenuse being across from the right angle. We don't have a right triangle. We can't use SOHCAHTOA, so we have to use law of sines. So step one, the law of sines. And what does the law of sines say? Little a over sine of A is little b over sine of B is little c over sine of C. So let's set that up. Now what, do we have a pair of sides and angles already? Yeah, we have B with B, don't we? So that's for sure what we're going to use, and then we'll match it up with A with A. So I'm going to do A with A and B with B. Notice B's across from B, A's across from A, always. So little a, let's see, let's go little a here. What's little a? That little a is what oh no, it's 104. 104 over sine of capital A, that's what I'm looking for, is little b, which is what, 44, over sine of capital B, which is 50 degrees. Okay, so there's my setup for the law of sines. And I'm going to go diagonal, diagonal. Remember how that works? 104 sine 50 degrees is 44 sine of A. All right. Next step, I'm trying to solve for A, so capital A, so divide by the 44, boom, boom. That brings down sine of A is 104 sine 50 degrees over 44. Now, how can I finish solving for A, right? Because my goal is to get A alone. It's kind of a sloppy A. My goal is to get A alone. How do you get A alone? Well, can we just come in here and divide by the sign on both sides like that? No, we can't do that. It's a common mistake. The reason we can't do that, this is not, sine A does not mean sine times A. If it's and because it's not multiplication, you can't undo it by dividing. It's not multiplication. You don't get rid of it by dividing. What do you mean it's not? It looks like multiplication. Sine's right next to A. Yeah, I know it kind of looks like multiplication, but it's not. That's why it's such a common mistake. So I really want to make this clear. You can't just divide. What is it? It's function. Sine of A is like f of x. See how I even say it? This is how math science people say it. They say sine of A. They don't say sine times A. Like we say f of x, not f times x. It's a function. And with a function, you can't just divide by f. It's not multiplication. It's plug-in. The A is a degree angle plugged into the sine function. So it's not multiplication, so you can't divide. Well, then what do? How do you get, because you do have to get rid of the sine. Right, we do. Let me write this over here. On the next line, we do have to get rid of the sine so that we can get A alone. So what do? Sine inverse. And got to do it on both sides, don't we? Why? Because if these two things are equal, then we've got to do the same thing on both sides, right? If this equals this, and then I do the same thing to both sides, if they were equal before and you treat them the same, they're going to have to be equal afterwards, aren't they? And so that's what we do. You do inverse. That's why we have inverse functions, because those they cancel out regular functions. So what will happen here is this will cancel that. Sine inverse cancels sine, and A is alone. That's how you do it, not by dividing, but by doing the inverse trig function. Okay, and then on this other side, this is all just calculator. Hit it. Make sure you're in degree mode there, because that angle's off 50 degrees is in there. So sine inverse of 104 times sine of 50 divided by 44. Oops, I hit something wrong here. Oh, no, it gave me error. Yeah, I thought I did something wrong. But I didn't. It gave me an error. What does that mean? This is impossible. It's an impossible triangle. The angle A does not exist. This is a make-believe fairy tale triangle. D and E does not exist. Yeah, it's impossible. When you get an error on your calculator and you double-check everything, make sure you're in degree mode, that's telling you this isn't possible. They made up a triangle. You can't have a triangle where you have 44 across from 50 degrees, and one of the other sides is so gigantic, 104. That's impossible. The sides won't connect up. The truth is, if you make that one side 104 and the other side is only 44, like this can't be a 50-degree angle and make them connect up. It's impossible. No way to make that triangle. So our answer is D and E, D and E, D and E. It's simply not possible to do it, right? That's like if I said, okay, here's 104, and this angle's 50 degrees, and I want the other side here, this B side up here, I want this to only be 44. It's short. So make a triangle out of that. Well, they don't connect up, right? There's no way you think, well, yeah, you can bend this to any angle you want. Yeah, bend it wherever you want. It's not going to make it to the other side, because this is fixed at 50 degrees and this is fixed at 104. That's an impossible triangle. There's not really a triangle that works like that, where you have a side that's 104 and an angle of 50 and the opposite side of 44. That's too short. It's not for a 50-degree angle. It's not going to work. So this is an impossible triangle, and that's how we figured it out. Our calculator told us error. And so when you get that, if you've double-checked that you put everything in right and you're still getting D and E, error, does not exist, then that triangle doesn't exist.